Всем привет! Hello everyone, my name is Mildir Yerbulikova. I am an American Corner Moscow volunteer and I will be moderating today's show. I'm so excited to be here today to continue the series of online meetings with NASA astronauts. And the reason for these events is to honor and celebrate the 45th anniversary of Apollo-Soyuz docking and the remarkable handshake in space. Today, our special guest is Marsha Ivins. Marsha will talk about the history of Space Shuttle and the humanity's first reusable spacecraft. After the talk, Marsha will spend some time on answering your questions. Please feel free to type them in the comment sections below, and we will do our best to answer them all. Please welcome Marsha Ivins.
Thank you. Thank you. It's a pleasure to be here with you. I have been asked to talk about the space shuttle, but in order to do that, I need to give a little bit of a background on human spaceflight history. So I would like to share my screen. And here we go. So all of the pictures that I'm going to show you in this presentation, I need to tell you, are taken by real people. None of them are illustrations, including this picture of the Earth that was taken by an Apollo crew at the moon. So what we have seen from space is pretty incredible. The space program, of course, started in 1961 with Yuri Gagarin. And in the United States, our first astronauts looked like these guys. These were the Mercury 7 crew. They flew an Mercury capsule here, which was pretty small, and it launched on a rocket that wasn't really much more than a ballistic missile. This is John Glenn, who was our first American to orbit. And those Mercury capsules landed in the water. So you can see he's landed in the water, then the helicopter would bring the astronaut back to shore again. The second program was the Gemini program, a little bit bigger rocket and a little bit bigger capsule. It taught us how to join two spacecraft together in space, traveling at 28,000 kilometers per hour, and also how to do a spacewalk, which would be very important later. And in these early spacewalks, you see this large umbilical here is what connects that astronaut back to the capsule. It provides his oxygen and it provides all of the pressure inside. There were two people in this Gemini capsule. You can see not very much room. And then in 1969, we finally sent people to the moon on the Saturn V rocket. There were three people in the Apollo capsule. And when they got to the moon, one stayed in the capsule as it went around the moon, and the other two went to the surface in the lunar lander. So remember, these are all real pictures. So here on the surface of the moon, this is the only part that will launch again. And that first landing on the moon in 1969, they stayed on the moon for all of 21 hours, and they wandered around for all of 250 meters. That's as far as they went. And yet that changed the way we looked at the world from then on. 5 more Apollo flights landed on the moon, and we had a little rover that would allow it to drive around some. And then the capsule here, or the part that was on the moon, goes back to rendezvous with the Apollo capsule. And then the capsule comes back to Earth and it lands under parachutes. And you can see how burned it looks from having come through the atmosphere. So all of these capsules, including the early Russian Voskhod and Vostok capsules, were designed to be used only one time. The Apollo program was canceled in 1972, but there were still some Saturn V rockets and Apollo capsules left over. So one of them was used between 1973 and 1974 to build the United States' first space station, which was called Skylab. So here it is. It had a telescope on the top, and it was supposed to have 2 solar arrays, but one didn't open. So the crew had to go outside and sort of put an umbrella over part of the vehicle so that it wouldn't get too hot. Inside, they had lots of room, and we had 3 crews who spent 28 and 50 and 80 some days on board that. And then in 1975, we had the Apollo-Soyuz program. So we had an Apollo vehicle and a Soyuz vehicle. And so here is the Soyuz capsule as seen from Apollo, and here is the Apollo capsule as seen from Soyuz. And here is the crew, the 2 Russians and the 3 Americans, practicing the handshake that they would later do in orbit. So here is that famous handshake. And Leonov, who was a very good artist, here has drawn a picture of Stafford. The Soyuz capsule, as you know, lands under a parachute, and it too is very burned from having come through the atmosphere. So all of these capsules were designed to be only used one time. In 1981, we started flying the Space Shuttle. It was designed to be reusable. The Space Shuttle was covered with 30,000 of these individual tiles. And when it was brought into the processing facility, it was attached to a lift, which lifted it up, and then it slid it down on top of the fuel tank and the rockets, and then it was on the crawler and taken out to the launch pad. So here it is on the same launch pad that launched the Saturn V rockets. The shuttle was made up of 4 parts: the Space Shuttle, the orbiter vehicle here, and the 3 main engines. And they are fueled by liquid hydrogen and oxygen that goes in this big orange tank, and then 2 solid rocket motors. So the solid rocket motors, in fact, all of it is reusable except for the tank. The solid rocket motors, after 2.5 minutes, come off, and then they land back in the water under parachutes, and they are towed back to land so that they can be reused again. The big orange tank is not used, so it burns up entering the atmosphere. And then after the shuttle has done its mission in space, it comes back and it lands on a runway, although the engines are no longer working, so it lands like a glider. And then each one of those tiles is inspected before the next flight. And if it does not land in Florida, where the launch site is, then it's put on top of the 747 and it was flown back to Florida to fly again. The suit that we wore in the shuttle starts over here. He's actually wearing a diaper underneath of that, and then he's wearing long underwear. And on top of the underwear, he's got this top and bottom, and all these little lines that you see in there is water lines. So that allows cooling water connected by these hoses here to a water tank to cool him. And then we put on this big orange suit. And then we had a helmet and a parachute. So this is what it looks like when we were strapped inside of the space shuttle. This is actually me right there. Inside the shuttle, we had 1,800 switches and circuit breakers. This is the front part of it, the front cockpit with the displays, and there are windows here you can't see all around. And then in the back is where we operated the mission once we got onto orbit. And there are windows all here. And this is what it looks like looking out of those windows once we are in space. The things we did in the early days of the space shuttle flights were to launch a number of satellites. A lot of them came with a spring action out of the cargo bay, and a number of them were put into space using the robot arm. Probably the most famous that people remember used with the robot arm is the Hubble Telescope. So this is the telescope. It was carried up in the cargo bay of the shuttle, picked up by the arm and put into space. And periodically we would have to go do repairs on it. So the shuttle would fly up, it would use the robot arm to pick it up, stick it in the cargo bay, and then crews would go outside for a spacewalk to do repairs. And repairs actually meant opening the telescope and going inside. And when we repaired or replaced electronics, this is the size of an electronics box that would be replaced on the Hubble telescope. Once it was repaired, then you would pick it up with the robot arm again and leave it back into space, and the shuttle would back away. So we did that a number of times for the telescope, which is still operating today. In 1995, we started flying to the Mir space station, the Russian space station. So this is a picture approaching the Mir. And these, like I said, are all real pictures. This is how the shuttle approached and connected to the Mir space station. And we had a number of flights, and here is another of those American-Russian handshakes on the first flight that we did with an American and a Russian together. Now, we had actually flown Sergei Krikalev on a space shuttle as a shuttle crew prior to doing these Mir flights. I had the opportunity to fly on the 5th Mir flight. And what we did, in addition to bringing supplies and cargo for the space station, is that we would leave a crew member. So in this case, we were leaving Jerry Leninger here, and then we would bring a crew member home. So we brought home John Blaha here. And the crew, Valeri was sort of fascinated by my hair. He thought that was pretty funny. And so every time he would come over, he wanted to have a picture taken with my hair. This is a picture I took of the shuttle nose when we were docked to the Mir space station out of one of their windows. As the years went by, we put a number of things in space with the shuttle cargo bay, but in the last 10 years, starting in about 1998, we used that cargo bay to build the International Space Station by taking up each piece of the space station one at a time. So this is the very first part that we picked up. So we came close to the first Russian piece that was in space, picked up this one and connected it. So now we have this, which was a node. So this allows us to put a piece here and a piece on all 4 sides. And then here was the first Russian portion of the space station. In the next couple of flights, another Russian portion was added. You can see here's a Soyuz. And so the crew arrived in the year 2000. Here is that first node part. A solar array was added. And in 1997, this is the way it looked when I approached on my last flight, bringing the first US laboratory module. So this is a picture that actually Sergei Krikalev shot of us as we were approaching to attach to the space station. So once we were attached, the job was to use the robot arm to lift up that laboratory module, rotate it around, and attach it to the space station, which we did. So this was the crew. This is the first crew on the space station, Bill Shepard, and of course, Sergei Krikalev and Yuri Gitsenko here, and then my crew. And so we were the second crew to visit them. And so here we are, after we have attached that laboratory module, was sort of playing around. Sergei was great, actually, in space. We were wearing our lucky socks, just so that everything would work well. And we also did some science experiments. So here he's getting hit with a 95-pound bag of water. If you ever wondered what that would feel like. This is me. And I'm not moving from one place to another, but I'm just stationary. And that's what you can do in space. We actually had also the opportunity to film an IMAX movie. And so here are Sergei and Yuri tossing Marsha around. So when we left the space station, this is the way it looked. So here's the laboratory module that we put on. And over the next 9 years, we continued to bring up parts of the space station. We would attach to the part that was there before and then added different things. So we added a robot arm, we added solar arrays, we added a big truss assembly that would allow us to add more solar arrays, and then we moved the arrays out. So there's 2. And then we added a third. This is a real picture of the space station, of the space shuttle as it is attached to the space station, which I thought was pretty cool. We added 4 solar arrays. We have laboratory modules from the Japanese Space Agency and the European Space Agency. And this is the way the space station looks today. And this is the crew that's on the space station now. We have 3 Americans. These 2 guys just arrived on the SpaceX vehicle, and 2 Russians. So this is what it's looked like. You've seen a little bit what it looks like to be in space. And just to show you that that picture is real, here's how that was done. Without any gravity, there is no up. So each one of these guys thinks that they are up. There's also no fashion sense, so that's the bad shirts. Without gravity, you can lift very heavy objects, or you can even be Cirque du Soleil if you wanted to. And you cannot walk, you have to fly. So not a lot of people fly, but here's the way you move without any gravity. Notice his feet. This is on board the space station, not the space shuttle. So here's another thing. This is a demonstration of the ice skater. So without any gravity, you can spin. When you open your arms, you slow down. You close your arms, you spin up. And you can spin all day long and never get dizzy. So here's another thing to try. We ask you, please don't try this at home. And here he's trying to do that same thing that I did, but guys can never really get the hip action going just as good.
Okay, good enough.
So you've seen people floating around. What happens if you want to stay in one place? Well, on the space shuttle, we had these loops taped to the floor that you could just slide your toe in. And on the space station, there are those same loops that are placed all around the space station, so that if you want to work in one place, like he is here, you can keep your feet restrained. Or you can just loop your toes around something if you need to hold on. This is a ball of water. And in the absence of gravity, surface tension is the strongest force, holds that ball of water together. This is a bowl of orange juice. It's much more photogenic. And here's what it looks like making a ball of water. So the water is in the bag, and it comes through this straw. So he's making a really big ball of water because, you know, he's a guy. You can see all the little balls of water floating off here. Now he's taken a GoPro camera and he's thrown it inside the ball of water, and it sticks because of surface tension. And here's what it looks like from inside the ball of water looking out. Now the reason I show you this video is this next part here. See the water on his hands? That's surface tension, and liquids will attach to your hand. So hold that thought. We're going to talk about that in a minute. Normally, drinks are in these bags. So this is orange juice here. There's a powder. You put water in it through a water dispenser. This is coffee with cream and sugar, and you put in a straw and you drink it. There is no refrigerator and there is no oven. So all the food has been already cooked, and then it's been freeze dried or vacuum packed. So it's put in these little packages here. And these packages are, well, here's one of them. This is creamed spinach. Here's cornflakes. And you rehydrate that by attaching that to the water hydrator, and then you select the kind of water that you want. We don't eat with a plate and a knife and a fork. We eat with spoons. Here on the space shuttle, we didn't have a table, so you can see his feet are in those loops. He has a tray attached to his leg, and the food packages are Velcroed to the tray. And here's his drink bag floating out in front of him. On the space station, there is a table so that you can hold the packages down with a strap, and then you use those spoons to eat your food. And then all of your spices are in these liquid bottles in the back. The Americans provide half the food and the Russians provide half the food. This is the Russian food. And here is a table on board the space station. So you can see the cans of Russian food. There's some of the American food, the drink bags, and then spices like garlic powder or anchovy paste and things like that. When you eat in space, you want foods that have no crumbs. So here is the perfect space food, peanut butter and honey, or peanut butter and jelly. Here's peanut butter and jelly on a tortilla. This is a piece of meat. The meat is in this package. It's already been cooked. And when you eat it, you open the top and you squeeze the bottom, and then it sort of comes out of the top like a popsicle, and you just chew it. You just eat it right from the package. On space shuttle flights, which were short in about 10 days, we carried all of our food with us. On the space station, because they are there for 6 months or longer, they can't keep fresh food. So every 3 or 4 months, a cargo vehicle arrives and it brings them fresh food. And so they're always thrilled when they see fresh fruit. And when they get fresh food, then they can be very creative in the things that they put together on their tortillas. Here's how you eat your M&Ms in space. So there goes the cream spinach. See, nobody likes that. Here's the M&Ms. This is the, the trash compactor. Here on Earth, when we have trash to get rid of, we put it outside, a trash collector comes and gets it. Well, nobody collects the trash in space. So you take your trash and you compress it in a bag as small as it can be. On the shuttle, we then brought it all home with us after 10 days or 14 days. On the space station, they hold that trash and wait for one of the cargo vehicles. When the cargo vehicle comes, they take out all of the good cargo and then they load it up with the trash they've been saving. And then that cargo vehicle is deorbited and burns up, so it burns up the trash. Exercise is very important, whether we're on a short shuttle mission or a longer space station mission. On the shuttle, we had a bicycle ergometer, so he's holding on, his feet are clipped into the pedals, so he can pedal here. And on space station, it's the same thing. He's holding on and he can bicycle like an ergometer. There is also a treadmill. We had one on space shuttle. This is the one on the space station. The treadmill is bolted to the floor, and then she's wearing a harness that holds her down on the tread, and when the tread moves, she can run on it. And in space station now, we have this resistive device that allows you to do the kind of exercises that you can do in a gym. So here he's doing essentially a bench press. And when he pushes up, that machine tries to push back down on him. So they exercise on the space station 2 hours every day. Here's how you take a bath. Remember the ball of water on his hand? Well, you take that ball of water and you put it on you. So you can see it's stuck to his face. So you rub the ball of water around on you. Then you take some liquid soap and soap yourself with a washcloth if you want. And then you spread on some more water, and then you take a towel and you take it off. And that's how you take your bath. So you do that sort of one body section at a time. Shaving is normal. We have electric razors. We have the straight razors here. On the space shuttle flight, you didn't really do any haircut, but on space station, after 3 months or 6 months, guys may, or the girls decide they want to have their hair cut. So here, when he's cutting the hair, he's got a vacuum cleaner hose that sucks the hair into the vacuum cleaner hose. Here's how you brush your teeth. You have toothpaste and toothbrush and you brush your teeth, but there's no place to spit. So they tell you to swallow the toothpaste. Here's how you sleep. In fact, this was part of my crew sleeping in the space, in the laboratory module after we put it on board. We had sleeping bags, and you get into the sleeping bag and you zip yourself up, and whatever you don't zip up will float. So your arms sort of float out in front of you. But because there's no gravity, your hand doesn't fall asleep. It just feels kind of funny out there. And then you use these blue straps, which are Velcro, to tuck yourself in. And then you put your head on the pillow, which is a piece of foam, and then you Velcro your forehead to it. And so that's how you would sleep. And if you think about when you go to sleep at night, when you relax your neck, you fall asleep. And so that piece of Velcro allows you to relax your neck. On the space station, each crew member has their own compartment. So she's in her own little sleeping bag there in her own space. So here's the toilet. On the shuttle, this was the shuttle toilet. So this was the hose to collect liquid, and this was the seat that would collect solid. And then all of your trash, when you were done, went into here. And when you were ready to collect liquid, you turn this hose on and it sucked the liquid down into the tube. Same thing on space station. This is the toilet. It's a Russian-made toilet. And so the hose is used for both men and women to slide your feet under the straps here, and you hold that hose to the right place for liquid, and it sucks the liquid down the tube and into the back in a tank, where it is then reprocessed back into drinking water again. For solid collection, You open that lid and you put a bag in here, and then you close the lid to put your solid waste in there. And then you close the bag and you put a next bag for the next guy. And when that can is full, you put the lid on and put in a new can, and you wait for the cargo vehicle to come up so that you can throw those cans away. All of your tools, pens, pencils, everything that you use in orbit has a piece of Velcro on it so that you can attach it to the wall wherever you go. This is a picture from the space station, but even your clothing has Velcro on it so that you can keep things attached to you. We did a lot of experiments on the space shuttle, but we do even more experiments on the space station. We have glove boxes, we have freezers to keep things cold, and on space station, they are even doing some plant growth experiments. On both the shuttle and the space station, we have a robot arm. This was how we used the robot arm on the space shuttle. I've got a controller here and then one in the corner, and my windows and cameras. And here she's got the same thing. She's got two controllers and all of her displays in front of her to operate the robot arm. We do a number of experiments on ourselves to understand how the body responds in the absence of gravity, so that we can understand, if we spend longer times in space, how to properly prepare for that. And we did spacewalks on both the space shuttle and the space station. This is from the space station. This is the two women who did a spacewalk. And on both the shuttle and the space station, spacewalking was in the same suit. You're no longer connected with that umbilical to provide air and pressure. That's all in the suit, but there is a safety line that you always attach someplace to the structure. And because we use the spacewalks to help construct the space station, we put these handrails all over the outside of the structure so that the crew members could basically move hand over hand all over the structure till to do the work they needed to do. And you can see the two safety lines right there. You could even put a walking astronaut on the end of the robot arm and then take them to the location that they would need to work in order to do the job with their feet are restrained. If they came loose from that restraint or their tether line broke, which has never happened, there is a backpack that they could use to fly themselves back to the space station. So we have in fact tested that, but we've never had to use it. And everybody takes a selfie. So here is a spacewalking astronaut taking a selfie. Here is the camera. The camera is actually wearing its own little spacesuit. Looking through the window, no matter what vehicle you are in space, is always fascinating. So this is the windows on the space station. And here's what we see from our 400-kilometer orbit when we look down at the Earth. So we cannot see the whole Earth like that first picture that I showed you. This is the amount of the Earth that we see. And parts of the Earth are really fascinating. This is a glacier in Alaska. This is ice off of Kamchatka. This is water off the Gulf of Oman. This is the Andes in Argentina. These are mountains in the south of Russia. This is the Namibian desert on the west coast of Africa. This is the Sahara Desert and the Australian desert. So you can see deserts are all different colors. Some parts of the Earth are recognizable as you would look at a map. Of course, this is Italy and Sicily. And here is Italy at night. The night pictures are really cool. And when you see this night pictures, you'll see this glow line right across the top here. That is the top of the atmosphere. So all of the oxygen that we breathe is below that line. This is Florida in the United States. And here is Florida at night. And this is the waters of the Caribbean. This is Moscow during the day. And this is Moscow at night. Here is Baikonur. Runways, airports are very noticeable from space. This is the mouth of the Volga River. And this is the Aral Sea. This is New York City, continuing around the world. This is Central Park right here. And here is New York from at night. And here is Washington, D.C. and Washington at night. I think the brightest city at night is Tokyo, actually. So this is Tokyo at night. And one of my favorite shots here is Bangkok. This is Bangkok, but all these green lights are fishing boats. This is the Himalayas. This is a volcano in New Zealand. This is the Nile and the Nile River Delta. And here are shadows from the pyramids. And this is the Nile at night. We go around the Earth when we orbit, whether it was in the space shuttle or the space station, every 90 minutes. And every astronaut who has ever flown from any country has come back and said the same thing. As you orbit the Earth, you do not see the lines and the borders that separate the countries. So you don't see any real natural lines and borders. Sadly, you see the man-made borders. So this is the lighted border between India and Pakistan, the man-made border. You also see the footprint that we as humans have put on the Earth. This is a picture of the Mississippi River Delta. And I show you this just to show you the shape of it. Because in this next picture, here is that Mississippi River Delta. And all of this dark part here, this was the oil spill, the BP oil spill from a number of years ago. Under that smog is Beijing. All of these white lines here, those are contrails from airplanes. These were fires burning in the Amazon. Agriculture is interesting when you look at it. This is probably how most of us are used to seeing agriculture, but in some parts of the world, agriculture is done in circular areas like this. This is in Brazil. So the green parts are where water has been put in to grow things, and the brown parts are where either crops are not growing or the land's been left for a while. These are in Saudi Arabia. So these round areas are using fossil water from the center of the Earth, which is not replenishable. So the light ones are where the water has been used up, and the dark ones are where they are irrigating now. And there are thousands of them now in Saudi Arabia. We also see natural things that happen. So this is a hurricane off the coast of Florida. This is what a thunderstorm looks like from above. And all those white flashes of light, that's lightning on the Earth as seen from space. The light areas here, those are city lights. And here you can see the air glow. And this was the shadow of the eclipse that just happened a few weeks ago. As I said, we go around the Earth every 90 minutes. So for 45 minutes, we see daylight, and for 45 minutes, we see night. And that line that between the daylight and the night, we call the Terminator Line. So 16 times a day, we see the sunrise and the sunset. And because we are flying at a high inclination, we also have the opportunity to see the northern lights and the southern lights, the aurora. And when you let your eyes adapt, you can even see into the Milky Way galaxy. So that's the space station that has had somebody on board ever since the year 2000. So there has always been somebody in space. Until recently, after the shuttle retired in 2011, we were sending Americans on the Soyuz rocket. So this is the Soyuz capsule. And here's a landing in the days of COVID. So this is the way crews are recovered now, and everybody gets to wear a mask. And then just a few weeks ago, SpaceX did the first commercial launch. So this is a real picture of the SpaceX launch. And this is a real picture from inside of the two guys that were flying there. And here is the Dragon capsule as it approaches the space station. And here it is attached to the space station. So this is a real picture of the way it looks today. So where do we go now? I mean, the next thing everybody's thinking about is going back to the moon, just because we were at the moon in 1969 and 1972 doesn't mean it's easy to go back, but the moon is just a stepping stone to go on to Mars. This is a real picture taken from an orbiting satellite around Mars. And here's what's on Mars now. This is the Curiosity rover you may have read about. And just to show you the relative size of it, this is the Curiosity rover. This was the Spirit and Opportunity, and this was the little Pathfinder rover. And these are two normal-sized guys standing at the Jet Propulsion Lab where they have a Mars test track, essentially. So the biggest thing we can land on Mars is about that big. We also have a non-roving thing called the InSight, and it drills into the surface of Mars. And again, you can see it's not very big. So the whole idea of going to colonize Mars until we can land something bigger than this on Mars is not going to happen right away. But these are real pictures taken from those rovers on Mars, which are pretty cool, I think. Mars is about as far as we can go now with today's current technology. But if we had a better propulsion technology, we could actually go to the other planets of our solar system. And more significantly, to the moons of those planets. The moons of Jupiter, I think, would be very interesting. And then Saturn. This is a real picture from Saturn. And if you were at Saturn and you looked back, that's what the Earth would look like. And then beyond our solar system into our galaxy and beyond our galaxy into other galaxies. This is the pictures taken from the Hubble Telescope of other galaxies. And of nebula, where new stars are being born. This picture here, taken from the Hubble Telescope, covers the piece of sky that your thumb would cover at arm's length. So just a tiny little piece of sky. And each point in that picture is not a star. Each point in that picture is a galaxy. So think about that. That number of galaxies in that tiny little piece of space, how many galaxies there really are in the universe, and each galaxy having billions of stars with planets. So when people ask why we should ever go to space, I look at a picture like that and say, how can we not? Thank you. Over to you if there are questions.
Thank you, Marsha. That was really fascinating and spectacular views, and it was very, very interesting. And we have a few questions from our viewers. The first question is from Aleksandr, and it's, how do you cook hot food on orbit?
I'm sorry, that cut out. Say that again.
How do you cook hot food on orbit?
How do you cook hot food? Well, the food is already cooked. So there is an oven that lets you warm up the already prepared food. So you have hot water and you have regular temperature water. So if you wanted hot coffee, you put hot water in your bag of coffee. But you put hot water in the package of food, but then there's a little oven that warms it up. And then the Russian cans go in a little oven that warms the cans up also. So yes, you can have hot food.
Wonderful. And there is another question from Svetlana. What should I study in school if I want to be an astronaut?
All astronauts, I think, from every country have some sort of education in science, math, science, physics, chemistry, biology, physiology, one of the sciences, one of the STEM fields. So that's the area of study you probably should use. Geology. I mean, once we go to other planets, geologists will be very important. So if rocks are your thing, then geology would be cool also.
Thank you. There is another question related to how do you do your laundry? So it's very similar to how do you cook your hot food?
We actually don't do laundry. So on the space shuttle, we had a new set of underwear and a new shirt every day, but we flew short flights. You know, the early shuttle flights were 4 or 5 days, and in the end, they were maybe 10 or 14 days. On the space station, They wear their underwear for a number of days, and they wear their shirts for a number of days, and then they exercise in it. And then when it becomes too horrible to stand, they throw them away, or they use that to wrap up things that they are sending home. So like extra padding for the vehicles that bring things home, but they get a new supply of underwear and clothing when the cargo vehicles arrive. So you don't do your laundry.
Oh, I see. That's very interesting. Another question from Eugenia, instructor Evdoxia. That's a very interesting name. As an astronaut, what type of vocabulary do you find most useful in another language? And the second question, is it the conversational vocabulary or the technical one?
In Space Shuttle, we didn't actually have to learn another language. Even when we went to the Mir, we went to the space station. It was interesting on Mir, we spoke a half dozen words of Russian and they spoke a half dozen words of English. So our procedures were written page by page, line by line, Russian and English. And you find out you can actually communicate quite well without language at all. You know, so you can communicate with body language. And we spent 5 days with the crew having very little verbal conversations, but had a great time, you know, and we got all of our work done. On the space station, all astronauts, regardless of their country, are required to know English and Russian. And many of them, particularly the ones that come from the European Space Agency, speak 4 or 5 languages. The Russian is a technical Russian. That is what's required that you learn, because that's the way the communication is done from the mission control in Russia. And the conversational Russian is something that they sort of pick up along the way by being embedded in their training scenarios, so the amount of time that they spend in Russia.
I think something happened with my internet. There is another question from Alek, and it's a very interesting one. There are lots of videos on YouTube where astronauts answer differently to the question, have you seen the stars from the space? Some of them answer that the sky from the outer space is completely dark. The others say that the stars look amazing. So could you please tell me uh, how do they look like? What have you seen in your experience?
Well, we are only 400 kilometers closer to stars than you are on the Earth. So because stars are so far away, light years away, you know, they are not any different in size. The difference is we are looking at them now without the atmosphere in the way. So if you would go to the top of a mountain where there is no lights, so no light pollution, and a very clear sky, and you look up, you see big stars and you see lots and lots of stars. And that's sort of the way I remember it from space, without any light pollution, without the atmosphere in the way. Here on the Earth, when you look at a star, they twinkle because you are seeing that through the atmosphere. So there's no twinkling when you look at it from space because there's no atmosphere to see it through. So I think the stars, I mean, I've seen them look bigger and brighter from Earth, and I think that's probably an artifact of looking through the atmosphere, but you can in fact see more of them. And when your eyes have adjusted, and in order to do that, you have to turn off all the lights inside, and then just let your eyes get very dark adapted. And then when you look, you can actually see, it looks like fog. There's so many stars, but it takes a while to get your eyes adjusted to see that.
Thank you. There is another question from Alek. He's from Moscow Aviation Institute. How has profession of astronaut changed your approach to understanding the work of an engineer?
One of the things that we had to learn as astronauts was how to be a system integrator and a system manager. And what that means is if I was trained, for example, as an electrical engineer, as an astronaut, I have to understand how the electrical system works with the propulsion system and works with the computer system and how the people interact with that. So in order to understand how all of those systems together are going to give me the answer, the product, the ability, the tool that I need to do my job, I have to be able to integrate all of them. And that's not something that is usually taught in engineering school. That's something you learn when you actually have to figure out how to get a job done with all of those systems working around you.
Mhm.
That's a great question. Thank you for that.
And he has the second question, actually. If you had developed the space shuttle again, what would have you changed, or what have you done differently?
The space shuttle was an incredible design, but it was also designed with a little innocence in understanding the way things worked. So the shuttle sat on the side of the rocket instead of on the top, and so things could fall off of the shuttle, off of the tank, and hit it, which is what caused the Columbia accident. So the very first thing you would do is you would put it on the very top of the rocket. The second thing is to provide a emergency escape system for the launch window, which all the capsules have had, which the new capsules have, and which the shuttle was incapable of having. They just figure it was gonna be safe. It was going to work well. Everything was going to be fine. And of course it wasn't. And so as a result, we lost 14 astronauts in the entire program because of those two things. So those are the first two things I would have changed.
Mm-hmm. Okay. And another question from Yulia Balashova. What are the prospects for cooperation between Russia and the USA in the near future? Your thoughts on that?
You know, despite politics, which is everybody's worst nightmare, we've been cooperating. The United States and Russia have been cooperating in space since 1975. I mean, you know, what happens outside the Earth is independent of borders and boundaries and politics and religion and ethnicity. And I think, you know, we should keep it that way. And I hope we keep it that way. So I hope that we continue in participation with not just Russia, but all international partners, because it is much easier to do these hard, complicated things like going to the moon and going to Mars if we do it as a team, as opposed to everybody having to build all of the hardware and figuring out how to do all of it. If we did it together, we could do it so much better.
And how would you evaluate the prospects of the space programs of other countries besides Russia and the USA?
I think there are 60 countries that have a launch capability, I think, and 100 some countries that have some sort of a space program. So everybody wants to, you know, have a piece of space, whether it's for satellites or for human spaceflight or for planetary exploration. And it's the way people are developing. And I'm not the expert on international space programs.
Mm-hmm. Okay. There is another question. I think that's more technical one from Linur Gimranov. When the shuttle was ascending into space, fuel in the boosters gradually burned out, changing the center of the gravity of the whole assembly. So how was it compensated? And he thanks you for a great presentation.
So those solid rocket motors don't burn from top to bottom. They burn from inside to out. So the CG doesn't really change where it counts because it's not like you're burning propellant down. And when the fuel tank burned out its propellants, we were now going so fast and so high and without any atmosphere. The center of gravity is all accounted for, knowing what's going to happen as you burn those rockets out and you get rid of them. So somebody with a much bigger brain than mine figured out how that had to work in order to keep the center of gravity balanced. We were limited in the amount of propellants we could carry, the amount of cargo we could carry, and even the amount of things we could put in the cockpit with us to keep the CG in the right place. It was very, very carefully balanced. And like I said, smarter people than I were the ones that did that.
There is another question regarding the career of an astronaut, and it's how much time does it take to go through the whole process? How much does it take the whole process of getting applied as an astronaut to actually be in space?
So astronauts all have today, they all have probably a PhD or a master's and experience in a work field. So you have to actually come with a fair amount of education. So there's that amount of time. And then the selection process, the last time we selected astronauts in the United States, 18,000 people applied and 8 were selected, I think. So a number of people go through the selection process more than once. I myself went through the selection process 3 times. Then once you are hired, in the shuttle days, because we were flying anywhere from 4 to 8 times per year, you didn't have very long to wait until you were assigned to a mission. But in today's world, we fly 2 crews per year to the space station. So it's not very many, maybe 3 when we start flying the commercial vehicles. But still, they train for a mission once they are assigned for 3 or 4 years is how long the training takes. And from the time a crew is selected, or from the time an astronaut is brought in as a class, there is a 2-year training period for the class just to get the basics of how the space agency works, how the space station works, and that kind of thing. So it's not right away. It takes anywhere from 4 to 8 years probably until you fly.
And speaking of the commercial flights, what's your opinion about SpaceX?
Well, the way the commercial companies have decided to do their program is not the way is not the way the governments has done it. You know, the commercial people put together a space program that will satisfy their business case, which means they don't do the kind of testing, they don't do the kind of safety precautions, not to say that they don't provide some, but they don't do them to the same extent that the government programs have done because they can't afford to. So SpaceX was successful on its first crewed flight. The other commercial company that is building a vehicle to take crews is Boeing. And they were not successful on their first test flight, which is a flight that is supposed to go all the way to space station and back with no crew. They did that last November. And they got into the wrong orbit. Nobody was harmed. The vehicle got back safely, but they have to refly that flight again. So, you know, the government is sort of looking out to make sure that these guys, when they start taking US astronauts, can do it as safely as they can. But my jury is still out on how successful really these commercial programs will be. I hope they're as successful because I don't want to see any major accidents.
And with this basically 2 types of flights, the governmental flights and the commercial ones, how do you see the future of the space exploration and in terms of existence of this type of 2 types of flights?
So the thought all along for commercial space programs is that, and you know, I went to space 5 times on commercial spacecraft. I mean, NASA didn't build them. NASA wrote the requirements, and then they were built by commercial spacecraft companies. So they were built by Boeing and Lockheed and Pratt Whitney and Northrop Grumman and the major aerospace companies built them, and each one of those companies had hundreds and hundreds of subcontractors. And so they were built by commercial companies, but they were built to specifications that the government wrote down. The plan had been that as the government puts out those contracts to develop a capability like a space shuttle or a lunar lander or a deep space probe kind of thing, the government writes a specification, the commercial companies bid on it, they are awarded a contract, they develop the hardware, and then there is a capability. So now the government can take its development money and go do something else and pay that commercial company to be the supply chain.
Mm-hmm.
So if the government writes a specification for a lunar lander and a commercial company provides that under those specifications, then the government then can go buy that lander repeatedly or pay that company to use that lander to provide the supplies that the base on the moon needs. And then the government can go off and develop something else. So that's the way originally it was envisioned that the commercial and the government programs work together.
I see.
Not in competition, but in partnership.
Yeah, that's logical. Yeah. And there are a few questions about what's the life in the space feels like and looks like. So there are a few questions. What do astronauts do if they get sick in space? Do you have some medications or?
We try not to get sick in space. So we are quarantined before we fly so that we're not bringing colds or coronaviruses or anything like that. We get medical examinations regular to make sure that we are not having anything systemic inside that could be a problem. If we happen to get sick or injured, injury is more likely, that you cut yourself or you hurt yourself banging into something. But if you do have a medical problem, there is somebody always trained on the crew, whether it was a space shuttle flight for 14 days or a space station flight for 6 months, somebody is trained to be the doctor. Quite often there is a medical doctor who is one of the astronauts and they become the doctor. And then there is always a doctor on call in mission control. And then there are a number of medical devices on board, especially on the space station, things like defibrillators and intubation kits and things like that, and IVs, and a big drug kit. So basically, the space station crew is trained in emergency medicine. They actually spend time in emergency rooms, learning how to do emergency procedures in case they have to. And in the worst case, if somebody is so sick, a heart attack or a stroke or something completely unforeseen, you can come home every 24 hours. You would put on the space station right now, you would put the 3 crew members, the sick one and the other 2 portions of that crew in the Soyuz and come home. And in the space shuttle, we could deorbit to land within 24 hours of a major medical facility anytime.
Okay, great. Thank you so much, Marsha. It was very interesting. The presentation was absolutely amazing. And before we wrap it up, I just wanted to remind you that on Wednesday, July 15th, there will be a final space talk with Nicole Scott and Gennady Padalka. They will talk about the specifics of their work and challenges they had to face in this space. The event will be both in English and in Russian. Again, thank you everyone for watching and for your questions.
Thank you. Bye.